In this video, I'm going to talk about some more ways that we can correct errors in our programs. I'm a little concerned with some of you that it seems like you're not developing the proper skills to be able to deal with the errors in your code. And that's really important going forward, not just in this class, but in the rest of your classes here and in your career as a programmer, if that's how you end up. So I think it's important that we all take a deep breath. I see a lot of panic sometimes. You get an error message and you're immediately going to ask me or, you know, Google it or chat GPT it or go to a website like Stack Overflow to ask for help. And I think that's the wrong approach. I think that you're short-circuiting your learning process by doing that. Okay. So by this point, you've had C++ for all last semester and 5 weeks of this semester. You should be developing a feel for what could be causing the error, which will give you a clue on how to fix it. Note that I'm not saying don't ask me for help. You certainly can ask me for help, but that can't be your first strategy, or it shouldn't be your first strategy. Okay. And something similar, many of you seems like you're having trouble copying files. We do it every week. So I try to put the command out there, but you really should have figured that out by now, right? This is not something that you should ask over and over. So in a college classroom setting, not a big deal. I'll answer the question, although I may give a smart comment when I do. But this is an important thing to think about long term. So part of the job of a college class is to prepare you for the workforce. I can tell you 100% if on the job you were told how to copy a file and you ask again, I would seriously question your dedication and commitment. That's why it's important on a new job. I always tell people, have a notebook or have a file on your phone that whenever anybody tells you anything important like that, you write it down. You know where to get it. It's not a good look if you're told something one day and then you keep asking over and over. Now, how do you do that again? Yeah, you should never have to tell people anything twice. Just as a trying to make a good impression. Again, I'm not going to withhold it or fire you from the class or anything, but it's something to think about. You know, if someone tells you, I mean, if you had me last semester, especially, you've been copying and moving files since January, okay? You should have it either written down or have it figure it out. If you're having trouble understanding how those work, okay, we can do a quick, they're both the same. CP for copy means you're going to have two when you're done. MV for move means you just have one. It's always the original file, whatever that file name is, space, the new file. Okay. Always original to new. If we're copying and we omit one of those, so we're copying from some directory, say it's in our SRV slash CSC 2180 directory. Okay. That's the from. It's going to remain the same. So I put that period there just to say it's the same. If I wanted, I could just type original again. If that makes you happier and understand it more, do it that way. All we're doing is the shorthand by putting in a period there. We're just saying to keep it the same. And if you get the error message that no destination file name given, that should remind you, oh, I need to specify what I want it to be called. The period means call it the same thing. Okay. So that's kind of a preface to what I want to talk about. And these are some errors that we get in G++ a lot. We all do. That I want to show some examples and how to go about them. Okay. Remember, whenever you get a page full of errors, the first thing you should do before anything else, scroll up and find the first error. No other error matters. You can have a program that gives you 1,000 errors and you fix the very first error and you have zero errors. Okay, so that's important. You don't care about any error except the first. Okay. Uh, the second thing is to read that error message. Read what it's saying to you. Okay. If it specifies a line number, look at that line number. Think to yourself, if this error is happening, what must be going on? And that goes a long way towards solving it. Okay. So the first error, there's not an example of because it's pretty straightforward. It's a missing semicolon. Okay. And the error message will say expected a semicolon, pretty much. Okay. And I don't get a lot of questions about those. So I assume that you're probably figuring those out. Okay. The second type of error we do get a bit, and that is comparing int versus int star. Okay. So it'll say something like, you can't compare an int and an int star. Okay. So you can think about what in the heck does that mean? Okay. What that means is that on one side of a double equals, we have an integer. On the other side, we have a pointer. Okay. And we can't do that, right? That's illegal. Okay. So let's take a look at an example of that. And it's good that it has that issue. If not, it just wouldn't make any sense. Okay. So I want the mismatch type here. We see this a lot. It seems people they're using node type, which is a pointer, comparing it to a number. If you want to compare it to a number, node type info or node type data, we sometimes call it. I think it's mostly info. Node type info in most of our examples has been an integer, and you can compare that. You can't compare the pointer. It's going to give you an error. Okay. So in this case, we have int x equal to 5. We have int PTR, a pointer to an int that's set to the address of x. Okay. So now in our list here, we have if x is equal to the pointer. Okay. We can't do that. Okay. X is a value, an integer value. Pointer's a memory address. Never going to work. You can dereference that pointer if you want. That works. Now we're okay. Okay. But without it, if we were to run this, it's going to give this error. Okay. And this tells us exactly what the error is, and it even underlines it. Okay. ISO C++, which is what we're using, the C++ version, forbids comparison between a pointer and an integer. Okay. So on this line, line 9, we're trying to compare x equal to PTR. Okay. And that comment that was from my code. So we know one of these is an integer, one of these is a pointer. Okay. How do you fix it? You probably don't want to compare pointers, so change the pointer by dereferencing it, or you've got the wrong variable. Okay. That's how you fix that problem. Okay. The next kind of variable we get, which I think is also relatively straightforward, and that's when you have an undeclared variable. Okay. And this is often when you have a typo. Okay. So in this case, just out of the blue, we just say total equal 10. What is total? We don't know. It's undeclared. Okay. Again, if we try to compile that, it's going to tell us pretty clearly error total was not declared in the scope. Okay. So what's wrong? Total was not declared in the scope, right? That's it. If you see this and throw up your hands and send me a text or dial 911 or phone a friend, we're looking at it wrong. This is simple to fix. Total is appearing the first time in your code, and it clearly hasn't been defined yet. So it needs to have an int total somewhere or an int in front of this. All we have to do, really, if we wanted, we could just do this and say int total equals 10. Now we're good. Okay. That's all we have to do. So don't be afraid of the error messages. Okay. The fourth error we're going to talk about, our old friend, the segmentation fault. Okay. And again, the segmentation fault requires a few more steps sometimes to fix. Okay. So we have our segmentation fault error here. So in this case, we've set an int array int star, so a pointer to an int array, so a dynamic array is equal to new int 5, okay, which means we've reserved spaces 0 to 4 are valid. We try to go to ARR10 is equal to 42, okay, and we don't have access to that. So we can see sometimes this is not going to give us an error necessarily. Let's see if it does when we run it. It does not. That one's okay. And the reason it's okay, it's still a problem, but it's okay. Um, it's not okay. It's not giving us an error. So the reason is that we don't check bounds in this, but it's certainly possible this is still wrong code, and you're going to find out when you try to run things with it. If we were to run this, let's just see. This is another good example of what we could do. Okay, so if I run that one, it's going to print. It's always print 42. Now that's interesting. Now I've confused myself. Oh, I've set it equal to 42. If I were to just print out, let's try that. Um, the reason it's not getting an error, we're just at 10, which means we're still in our memory space. If you went far enough, then you would have trouble. So if we try to see out that, okay, we should get some random value. That's all it's always going to do. That must be some kind of defensive thing that it's not letting get crazy. In the past, you would just get randomly crazy values when you went too far. 10's pretty close, so we're not causing a big issue. We're only 5 past where we were. Okay. We've talked, and I didn't mention it, but I've put a couple of PDFs out there on frequently encountered errors and on these same codes we're talking about. And the way that we're most likely to get a segmentation fault that will always fire is if you don't, for example, if we were to do this, where we would forget to initialize it. Okay. So this happens a lot in the dynamic array version of the stack program. Okay. So if we do something like this, it doesn't matter what my variable is. It's going to give us this invalid pointer and an aborted core dump. Okay. Same issue as a segmentation fault. Okay. So you can't do that. Okay. So you have to make sure you're actually, so when you see a segmentation fault, it's one of two things. You're either dereferencing a null pointer or you've gone too far. You have an off by one in one of your codes. Okay. Or you never allocated it to begin with, which would make it null. So that would be fine. Okay. So we've talked a lot. There's a whole video on segmentation faults. Again, to fix a segmentation fault, you do the -G when you compile, and you use the GDB compile, the GDB debugger. We've been over that a bunch. There's a video on it. You should know that. You shouldn't have to ask that. If you don't know it, get a notebook, write it down so it's always there. Okay. It does not read well when you ask the same question every day in class. Okay. At some point, you just got to internalize that. Okay. Um, especially moving forward in your careers. Okay. So after segmentation fault, next thing we're going to talk about are mismatched brackets. This is a simple example, but there can certainly be more complicated ones. If you're using Emacs, which most of you are, there's an advantage, and VI may do this as well. I don't know. It will give us indentation if things are wrong. It'll mess up the indentation. Okay. So in this case, we've only got an opening int main and we don't have our closing. Even if we have our return 0, um, we don't have this closing bracket. Okay. And that's kind of where the problem is. It's more likely to be a problem in a program if you have a switch and a for and all these multiple things. Okay. That's when you can get an issue. Okay. This is like exactly what it tells you here. It expected a semicolon and it tells you right where it's at after this line. So you know where to put it. Okay. So shouldn't be any worries on that one. That's pretty straightforward to take care of. The other thing that we see sometimes that doesn't show up as an error, but it certainly is. And that's the assignment versus the equals. Okay. It's the one equal sign versus two equal signs. Okay. Okay. Apparently that's not what I called it. On the right directory, I am. There we go. Okay, so in this case, we have int x equal 5. We're checking to see if x is equal to 10. We're going to say true. Okay. We're going to compile this. Okay, life's good. No errors. Going to run it. No errors. But it says true. Okay, which is not right. 10 is not 5. Okay. And this, in looking your code, you can always, if you want, I will often put in something here, to see, am I getting in the loop? Okay, because I shouldn't be. So I can see out. And I usually put something like this just so I can find it later and it sticks out in the code um, in the loop. Okay. If you've asked me questions, you'll often see me put a ton of print statements in just so I can track what's going on. Okay. So I do this, I do that, and you see I'm in the loop, and that's a problem. So what's causing that? It's this right here, right? In our that's the wrong program. That's the right program. We're saying here x single equals. Um, this will always be true. Doesn't give an error. I wish it did because it's never correct. But if you say x equal 10, you're assigning x to 10, that always reads as true. So this if will always fire no matter what. So you have to put in two equals to fix it. Okay. So that is the fix for that one. Okay. So that really is kind of the big things I'm seeing people do. Okay. The other thing that you can do when you're compiling is you can do a dash wall, which is all warnings. And I fixed the error, so it wasn't an issue then. But that will be a way that you can help. Okay. But read those error messages carefully. Okay. I should have mentioned this earlier, but I assume people are going to do things that I would do, and I don't. No one does things like I do, which is okay. I would have a little notebook that every bit of programming wisdom or programming insight that falls into your head, I'd write it on that little book. You've got your own little book of custom hints for C++. So every time I mention something in class, every time you see code someplace else, every time that you make a discovery in your own programming, put it in the book. So you never that you always have with you, or put it in a file on your phone so you don't have to go searching for it. Okay. By now, you should know how to copy files or be able to get to it instantly. You shouldn't have to ask. Shouldn't have to ask about moving files. Shouldn't have to ask about how to use the debugger for segmentation faults. Okay. So let's try to start moving those into our memories so we can focus on the bigger issues. And again, I encourage you when you're doing your programs, I've got a whole big long, nearly hour-long video of me doing one of the programs. I think the process is not correct for some of you. Now, everyone's process is differently, but programming is not hard. It's a bunch of little simple things added on top of each other. So if you try to do them all at once, you're destined to failure. But if you can break it down, where do I start? What do I have to do next? What commands do I have at my disposal? I think it's going to be a lot more straightforward. I want to see you guys succeed. I want you all to be good programmers. And some of you already are. So I'm already preaching to the choir to some of you. So you don't need to worry about this. But for all of us, it's always worth looking at our techniques and the way we get things done and try to find ways to be more efficient in our programming and more expressive and have more ability to do more kinds of programs. Okay. So if you have any questions about any of this, make sure you let me know. I think on Wednesday of this week, we're going to have just an open day to ask questions on any of the homework problems or anything that you don't understand. So I encourage you to get yourself a little notebook or open up a file on your phone on Wednesday and not only questions you have, but questions everybody has. Put these into your own custom C++ guidebook. I think it will be helpful.